Question 8. So part 1. The secret here is to choose to divide through by cos 3 theta. So we get sine 3 theta over cos 3 theta minus root 3 cos 3 theta over cos 3 theta equals 0 over cos 3 theta. Sin over cos is tan, and cos divided by, well, something divided by itself is just 1, so that just leaves us with minus root 3, and obviously the right hand side is 0. So now we've only got tan in here. So if we choose to add root 3 to both sides, we get tan 3 theta equals root 3. Now let's let capital X equal 3 theta. So by substitution we need to solve tan capital X being root 3. We also then need to change our boundary, so theta isn't between pi and 0, but because we've multiplied x, capital X is 3 lots of theta, our boundaries are now between 0 and 3 theta. So using all silver toy cars, we get our first solution by inverse tanning both sides. So x equals inverse tan root 3 in radians gives us pi over 3. So that is our first solution for capital X. Now we're looking for the positive solutions for tan, so between 0 and 3 theta. So our first solution is pi over 3, our second solution is round to there, which is 4 pi over 9, and our third solution all the way around back up to here is 7 pi over 3. Oh sorry, I think I said over 9 then. What I should have said is pi over 3, 4 pi over 3, 7 pi over 3, excuse me. They're the three solutions for capital X. Now we need to convert back to theta by dividing each of these by 3. So rather than pi over 3, it's pi over 9 and so on. So those are our three solutions for theta. Now part 2, given this, find cos x in terms of k. So let's first start off by trying to get the same trig ratio throughout. So remembering that sin squared x plus cos squared x equals 1, sin squared x is the same thing as 1 minus cos squared x. So we substitute that in here, so that we've only now got cos in the equation. Then multiply out the brackets, we see the 4's cancel. I've then chosen, I've then made it equaling to 0 by adding k to both sides, and then just to make it a bit more easier to consider the quadratic equation, I've chosen to multiply through by minus 1, so basically change each of these signs. So I get 4 cos squared x minus cos x minus k equals 0. Now this is just this can be factorized. No, it can't be factorized. Sorry, it can be solved, but it doesn't factorize. So we have to use the quadratic equation. So a is 4, b is minus 1, and c is minus k. So substituting that into minus b plus or minus the square root of b squared minus 4ac over 2a, we got cos x being equal to this. That's our answer for part 2 part A. Now for 2 part B, we're told to work this out when k is 3. So k is 3. 16 lots of 3 is 48, add 1 is 49, square root of 49 is 7. So we've got 1 plus or minus 7 over 8. So when we add the 7, we've got 8 over 8 being 1, so cos x equals 1. And when we take away the 7, we've got minus 6 over 8, or minus 3/4. So we need to find all the solutions for cos x being 1, which is just 0, because if you look at our boundary, it's less than 360. It doesn't include 360, so that's our only solution from cos x being 1. And with regard to cos x being minus 3/4, we get our first solution from our calculator of 139. So that's this angle around here. Again, using all silver toy cards, we're looking for all the negative solutions for cosine. So in this quadrant and this quadrant. So our second solution is all the way around 180 plus the 41. So that's our 221. So from here we get the two solutions of 139 and 221. So our three solutions are 0, 139 and 221.